Continuing on with our Geometry Semester 2 Final Study Guide. In this problem, I want you to find the area of triangle ABC with vertices at 1, 3, 7, 3, and 5, negative 3. Well, the first thing that I'm going to ask you to do here is plot those points and draw the triangle. And then it's really easy to see, hey, I've got a horizontal line. I'm going to count those spaces, so that's 6 units. And then I'm going to draw in my height of my triangle, and I'm going to count that, and that is 6 units. Recall that area of a triangle is 1/2 base times height. I'm going to put in my numbers, and I get that this triangle is 18 units squared. The sum of the measures of the interior angles of a convex octagon is, well, recall the formula for the sum of the measures of an interior angle of any shape, and then realize that an octagon has 8 sides. So I'm going to put that in my formula, and I'm going to get 1080 degrees. Given that the length of segment ED is to the length of segment BA in the same ratio as the length of segment EC is to the length of segment BC, find the length of segment ED to the nearest tenth. Okay, so I'm actually going to use this proportion and just plug in numbers. So ED is what we're finding. We're going to call it X. BA is 36. EC is 38. And to find BC, you have to add 38 and 19. Okay, now I'm just going to cross multiply and then solve this. And I get that X equals 24. Okay, I'm going to go back and make sure, yeah, good, I got all that. All right. The measure of each interior angle of a regular decagon is, again, recall, the measure of each interior angle of a regular decagon is. So recall that the formula for each individual angle in a regular shape is 180 times n minus 2 divided by number of sides. And a decagon has 10, so I'm just going to plug those numbers in, and I get that each interior angle is 144 degrees. Find the sum of the measures of the interior angles of the polygon below. Well, the sum of the measures, remember that formula, is 180 times n minus 2, n being number of sides, and I counted the number of sides on this. It's 5. I'm going to plug that in and get that the sum of the measures of a pentagon is 540 degrees. Now on this next one, the first thing I want you to do is change the question. Cross off the measure of the mid segment and type in or write in find the area for this trapezoid. Recall that the formula for area of a trapezoid is 1/2 base 1 times plus base 2 times the height of the trapezoid. And then I'm just going to plug in numbers and solve this. And I get that this trapezoid is 39 feet squared, has an area of 39 feet squared. Use the figure. Segment SR is tangent to circle Q at point R. What can you conclude about the measure of angle QRS? So that is this angle right here, QRS. Well, we know that if a line intersects a circle as tangent, then the radius at that point of tangency creates a right angle. So I can conclude that the measure of QRS is 90 degrees. A box of cereal is a rectangular prism and measures 11 inches by 3 inches by 14 inches. What is the volume of the box of cereal? Well, normally, I would have you sketch this, but this is a 3-dimensional figure. So what I really want you to do is just remember the formula for the volume of a prism is the area of the base. That capital B means area of the base times the height of the prism. Well, this is a rectangular prism, so my base is a rectangle, so I can change that to length times width times the height of the prism, and I'm just going to plug in numbers, and I get that the volume of this box of cereal is 462 inches cubed. All right, given we have here in circle O is that the measure of major arc BAC is 310 degrees, and I want you to find the measure of angle A. So let's draw a major arc there. That's 310 degrees. Well, here is the angle A they want us to find. Now that is an inscribed angle, so I know it is exactly half of its intercepted arc. So if I can find the measure of that arc, then I can take half of it and find the measure of angle A. Sorry about the clock. Okay, so a circle has 360 degrees. That major arc was 310, so what's left is arc CB, which is 50 degrees. Measure of angle A, which is the inscribed arc or inscribed angle that makes that arc, is half of that. So measure of angle A is 25 degrees. How many degrees does a minute hand move in 10 minutes? Well, let's kind of sketch that on our clock there. So I'm looking for the degrees of that angle right there. How many degrees does it move from 12 to 2? So what I'm going to do is I'm going to say, let's divide 360 by 12, and I get that every 5 minutes is 30 degrees. So if I'm going 10 minutes, that's going to be, if I'm going 10 minutes, yeah, that's going to be 60 degrees.